Welcome to the Unit 5, Section 7 video on systems of linear inequalities. A system of linear inequalities is a set of two or more linear inequalities containing two or more variables. The solutions of a system of linear inequalities are all of the ordered pairs that satisfy all the linear inequalities in the system. So for example, we're going to tell whether an ordered pair is a solution of the given system. So for example A, we are given the ordered pair 2, 1, and we're going to determine if it is a solution to this system of inequalities. So very much like we did with equations, we're going to take the ordered pair and plug it into each and see if we get a true or false statement. So we'll plug it into the first one, put in 1 for y, negative 2, well, 2 for x, in this case it's negative 2 plus 4. Negative 2 plus 4 gives us 2, 1 is less than 2, so this first one checks out. Next, we have the second equation, or in this case, inequality. We are going to plug in our x and y. 2 plus 1 is 3. 1 is less than or equal to 3, so that checks out. So 2, 1 is a solution. For b, we're going to see if this point is a solution to the system. So we are going to plug in our x and y. We get 0 is greater than or equal to 4, which is not true. So we've already determined that this is not a solution to the system. We don't even have to check the second one. But if we were, you would find that it does check out on the second one. But it doesn't matter. If it doesn't check out on both, then it is not a solution. To show all the solutions of a system of linear inequalities, graph the solutions of each inequality. The solutions of the system are represented by overlapping shaded regions. So here are the graphs from example 1. Example 1a, we determined that 2, 1 was a solution. If we were to graph both of the inequalities on one graph, you'll notice that the overlapping shaded region, which is the darker shaded region here, indicates where all the solutions for the system are. And that point does lie within the system, so it is therefore a solution. Now in example 1b, we determined that it was not a solution to the system. And in this case, if we graph the two inequalities, you'll see the overlapping shaded region is not where the point lies. The point lies in one, but not the other. And that's what we found with the equations. It satisfied one inequality, but not the other. And so it is therefore not a solution to the system. So for this example, we're going to graph the system of linear inequalities and determine which plotted points are solutions. So in your notes, you have the plotted points already on the graph for you. All you have to do is graph this system of inequalities and see which points lie within the shared solution region. So to graph it by hand, we are going to want to take that first inequality and get y by itself so that it is in slope-intercept form. So you subtract 8x from each side, and then you divide each side by 4. So now that we have a system where both are in slope-intercept form, you can graph both of those inequalities and see which points lie within the solution. Now, you'll notice that negative 1, 1, and negative 3, 4 are solutions. They're both within the shared shaded region, so no doubt about that. 2, negative 1 lies at the intersection of the two lines, but one of those two lines is dashed, which means we do not include the solutions of the line. So therefore, it is not a solution, and neither is 2, negative 4, because it lies within the solution region of one inequality, but not the other. Previously, you saw that in systems of linear equations, if the lines are parallel, there are no solutions. With systems of linear inequalities, that is not always true. So for this example, we're going to graph these inequalities, and we're going to describe the solutions. So we're already in slope-intercept form, so if you were to graph both of them, you would get two parallel lines because they have the same slope, but different y-intercepts. And you'll notice that one is shaded to the left, the other shaded to the right, but there is no overlapping shaded region, so therefore there is no solution. For B, we have two parallel lines, and one is shaded below, one shaded above, and they do have an overlapping section. And so that overlapping section is where the solutions are, and so are where we have points along the solid line. So anywhere along the solid line or within the shared shaded region is a solution to the inequalities. For C, we have these two, which when graphed, we have the solutions shaded to the left of one of our two inequalities, and that is the one for y is less than or equal to 3x minus 2. So our solutions can be described as the same solutions as the inequality y is less than or equal to negative 3x minus 2, because that inequality itself encompasses all the solutions for the system, because it's where the shared boundary is, and it's where all the shared shaded region is as well. So let's do some application examples here. A surf shop makes a profit given in the table. The shop owner sells at least 10 surfboards and at least 20 wakeboards per month. He wants to earn at least $2,000 a month. Show and describe all the possible combinations of surfboards and wakeboards that the store owner needs to sell to meet his goals. And then we're going to list two possible combinations. So let's let X be the number of surfboards and Y be the number of wakeboards. We know that that the shop sells at least 10 surfboards, so X is greater than or equal to 10. And he also sells at least 20 wakeboards, so Y is greater than or equal to 20. He wants to earn at least $2,000 a month. So if he sells each surfboard for $150, that's 150X, plus each wakeboard, which is 100Y, that in total needs to be greater than or equal to 2,000. So we're going to take that last inequality, we're going to solve it for Y so that we can plot it. And now we have a system that can be plotted on a graph by hand. And so when we plot all three, this is what it looks like. And so you'll notice that the shared shaded region, or the darkest shaded region, is in the upper right-hand corner. So with this in mind, we can describe our solutions. To meet the sales goals, the shop could sell any combination represented by an ordered pair of whole numbers in the solution region. Answers must be whole numbers because the shop cannot sell part of a surfboard or wakeboard. Two possible combinations are 15 surfboards and 25 wakeboards. You could also sell 25 surfboards and 20 wakeboards. Those are both solutions that fall within our solution region. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.